regular calculator over here. The reason I was so slow last time is just because my laptop was super slow. So I'm using a
Oh,
different
it
one.
wasn't you with.
Yeah,
It wasn't you
I was
with.
the one with the iPhone.
Yeah.
Oh, okay.
My
Did you
calculator is
find
great.
one?
So I didn't really look. I just ended up making a spreadsheet on Excel that works pretty well.
Oh, because I found like a super sweet calculator that you can actually just like draw in the equations with your finger, and it will like do the math for you. It's pretty
Wow,
sweet.
that's awesome. I'll have to check that out. What's it called?
I just typed in calculator on the app thing, and it's like the icon is a blue cubed square sign. So like a
Okay.
blue with a square root and a 3 underneath it. It's
And,
pretty sweet though.
and it's free?
Yeah, it's free.
Sweet. I'll have to check that out.
Yeah.
All right. So are we ready to start?
Yeah.
Okay, so
Yeah.
I went through um, individually and submitted it, but I had just read that like 5 minutes ago, and so I did all of the multiple choice, but I didn't
Oh
have
wow.
time to figure out all of the fill in the blanks, and so I don't know on those ones, but I have at least some of the answers already. So let me get those pulled up.
Good man. Wow, they have a lot of questions in this one.
Yeah.
31.
Holy crap.
Okay, so do you guys know what it is for number 2?
Oh yeah. Oh man. Okay. Just put pause for the first one, I guess. So yeah. Sorry, go ahead. Number 2.
So number 2, I ended up putting the first two. I put the number of animals in the local zoo and a randomly selected brand of toothpaste, and I got 0.67 out of 1. So would they all be categorical?
Yeah, age and years would also be categorical.
Okay.
Because
So
like
all
unless
three.
you can do like arithmetic, unless it's like a thing where you're working an actual problem, I guess, it's just categorical, if that makes sense.
Yeah.
Like so
Okay.
even if it's a number, it can still be categorical if they're not doing anything with them except like tracking them or whatever.
Right.
Makes sense.
Okay.
Okay.
Okay, and then the next one. So I ended up putting that 112 is a parameter and
I'll
100
bring
is
it.
a statistic, but that was wrong.
Okay.
The other way around.
So it says the mean IQ test score in the United States is 100. 20 randomly selected statistics students took an IQ test. The mean of their scores was 112, which the following statement is true. So I think the statistic would be. Oh, so you pick like the 100 is a statistic, and then 112 is a parameter.
Yeah, that's what I picked, and it was
Is
wrong.
it?
Oh,
I
I
was
would
gonna
have
say,
done that
isn't it
too.
vice versa?
Probably isn't this.
Yeah,
No.
probably. So do you guys know the actual like definition of those?
Yeah, because we didn't cover those, did we?
Well, I think that 100 is a parameter because it's just like something super general. It wasn't actually from that study, and so I think that the 112 is the statistic because they actually did the study,
Yeah.
and the mean score was 112.
Okay, yeah. I just looked it up. A parameter is a measure that describes the entire population. A
Okay,
statistic describes a sample.
Okay.
Okay. Cool.
So it'd just be the first and the last one, correct?
Yep.
Yeah. Okay, so the next one I did get right. It's a stratified sample. For number 4.
Cool.
Do you remember what the definition of stratified is?
I don't.
Isn't it like, huh? I could tell you the other ones, but not that one.
Let me look it up. A sample that is drawn from a number of separate strata of the population rather than at random from the whole population in order that it
Okay.
should be representative. And so I guess with that one, so it's about how each neighborhood like is similar within the neighborhood, but each neighborhood's different from other neighborhoods. And so
Yeah.
with a stratified sample, you would have a little bit from each.
Oh,
Okay.
okay.
Instead of like if it was just completely random, you might have mostly from you'd be pulling mostly from one neighborhood or something. So
All right.
I
Cool.
think yeah, that makes sense to me. Okay, question 5. I know that it's not systematic,
All right.
so I got this one wrong.
So this which type of sample scheme is implemented? Would it be a cluster? Cause
I don't really understand like the difference on lots of these. I'm not sure.
okay, so they're zeroing in on a particular district, and then they randomly select teachers from a certain grade. The experiment
I
is then conducted using all the students in the selected classes.
I think that cluster sounds correct out of the everything.
Yeah, because I don't think it's voluntary. I don't
Yeah.
think it's. I know it's not systematic.
It's not
I
a
don't think it's
simple random. I don't think.
stratified. So yeah, I think a cluster's probably it.
All right. Huh. Okay. It's hard not to get that one mixed up with systematic, though. Or not systematic, stratified.
Yeah. So online, the definition for cluster sampling is technique used when natural but relatively heterogeneous groupings are evident in a statistical population. It's often used in marketing research. In this technique, the total population is divided into these groups or clusters, and simple random sample of the groups is selected.
Hmm.
So does that seem to fit?
Yeah, because they kind of had a group now, because they're doing, like, say, in this case, fourth grade teachers from a certain district, and then I think they said they're randomly selected after that. Let's see, what's that what they said?
I think they selected all students.
Yeah, so they randomly selected the teachers, and then the students within those teachers' classes were kind of automatically
Yeah.
sampled.
Oh, okay.
I feel like it's like
I
three
have no
different
idea.
samplings all in one.
Yeah,
Yeah, this is crazy. Um,
and simple random sample, let me look that up.
I think that one's just like pulling names out of a hat. No system, no
Yeah,
nothing.
right. Well, I mean, I really don't think it's any of those middle three, and so it's cluster.
I think so too.
I mean,
yeah.
and we can submit it and see if it's wrong or not.
This
Okay,
next one's definitely simple.
Yeah,
Random sampling.
I think so too.
simple. Okay,
Okay.
7 is stratified, random.
Cool. Okay, a survey was taken of purchases at the crossroads. Open the data file. Crossroads purchases, and use this data to answer the next 3 questions. Oh crap. I just remembered. I can't use this. I don't have Excel on this laptop, so. Okay, I'm going to have to pull up my other laptop too and use that side by side.
Okay. So we're just looking for the mean of the purchases, right?
Yeah, I think so.
Okay, I can get that real fast. Okay, I got 477.
477.
Yeah. The mean of the amount spent. Yeah, do you want to run that and just double check? But I think it's $4.77.
I'll check it, yeah. Yep.
Okay, perfect. Okay.
477.
Oh, is that for the first question 8?
Yeah, question 8.
It says round to 3 decimals, so 4771.
Yeah.
Okay.
That's dumb that they would have us round to 3 decimals when we're talking about money, but whatever.
I know. Okay, so question 9, using software.
One or just. Sorry, was it 4.771 or?
Yeah.
Okay.
Yep. Okay, using software, calculate the standard deviation of the amount spent.
Okay.
How do we do that?
It's STD
Oh, yeah.
Yeah.
something point S.
stdev.s. It's
Yeah.
1911 or 1912. But if someone wants to double check that, that'd be great.
Okay. Yeah, I'm getting it on my other laptop so I can use Excel.
So we do stdev.s and then we do all of the amounts?
Yeah.
Yeah.
Okay. Would you get 1.911 or 9.912?
Yeah. Yep. Is that what you got?
Yeah.
Okay. Awesome. Now for the next one, I think I got this one right. So true for 10. Oh, we have to create a histogram for this one.
Yeah, how do you create it?
If you go to the insert button, there should be like some charts, and then one of them should say histogram if you like scroll over it. So you just select the purchases, and then you go to the insert tab next to the home tab. And it should have it right there.
So yeah, we're just selecting the prices, right? And then inserting a histogram.
Yep.
Okay. Cool.
Huh. Have you been able to find the histogram charts?
Yeah. So
I
yeah. So if you go to Insert, and then
Yeah.
if you click down to see all charts, then click on all charts, and then there'll be a
Oh, there
column,
it is.
and then there's
Yeah.
histogram.
Okay, gotcha. Got it. Sweet.
Did you get that, Jake?
Okay.
no, it's on my MacBook. I don't know how to do any of that. When I go to insert and chart, it won't like show me all charts. I don't know where to find that. I clicked on chart and it just has like column, line, pie, bar.
So I don't know if this is different from the Mac version to PC, but yeah. So if you click on Insert, and then you've got the chart section, and the bottom right corner of that section, is there a little arrow to expand?
I don't think so.
'Cause
No.
you'll have all of the little icons for the charts, and then the bottom right, there should be a little box arrow thing.
I don't think so.
Do you have a button for recommended charts?
Recommended charts? No, I don't.
Not really.
Huh.
I'm not really sure. I'll
That's weird.
figure it out after.
Okay.
I'll just get on YouTube and figure that one out after, so I don't have to waste your guys' time.
Okay. Yeah. Hopefully you can figure that out. 'Cause if you can, yeah, just get to the charts thing. If you can see something that says recommended charts later, it'll open up a new window, and then you just click on the all charts, and there'll be histogram. But if you're not
Okay.
seeing that, then I guess you can YouTube that later.
Okay. Okay, sweet. Thanks.
Yep. Okay, so down to question 11 now, right?
Yep. Here, I'll read it. Jessica Mayer and her research team measured the body temperatures of a sample of diving elephant seals. A thermistor was placed at a specific location on each seal to measure its body temperature. The body temperature of seals tends to decrease as they dive. The researchers estimated the typical body temperature of each seal at the time they initiate a dive and called this the representative temperature of the seal. All right. Thermistors were placed in the something sinus for the seals. The seal's body temperature at the start of the dive was calculated to be, and we got this table right here. Okay, so we gotta complete the following table. So we gotta find the deviation from the mean and square deviations.
Okay.
Huh. So the representative temperature then in this case is the mean. It's x. Yeah, okay, so it's a sample mean. That's, so
Yeah.
we subtract the sample means, or, huh. How are we supposed to know what the actual mean is if we only have the sample means?
Wouldn't we just sum all of the ones in the x column and divide by 4? Sum the representative temperatures and then divide by 4.
I
So
don't
find
see any
the
other.
average?
Because wouldn't that give us the mean out of those 4?
Oh, right. But these 4 samples right now are basically the mean samples, I think. Wait a minute. Oh yeah, that makes sense actually. At least
Yeah,
I think it does.
I think it does too. I got 38.075 for the mean.
38.075.
Yeah.
Okay, and then
We'll just find out how far that is from 37.91.
yeah.
Mhm.
So I got 0.165.
That's what I got too.
Cool.
Awesome. Are you there, Daniel?
Yeah.
Okay. So 0.165, and the next one, it wants B. So are we just squaring the deviation from the mean, but for B?
I think so. That's what it looks like to me.
Okay.
Yeah.
So that is going to be, I've pretty much got it.
Parentheses. So we do.
Okay, I got 0.68.
So did you just put like parentheses 38.075 minus no. What am I doing?
So I took this table and recreated it on Excel. And so I just took the value that I had for the slot underneath A and squared it.
Okay.
Okay. And what'd you get?
I got 0.680625, so 0.680, 0.68.
It was 0.680625.
Yeah, so it's
681.
0.681. Oh yeah, you're right.
All right. Cool. Alrighty. So do we need to find the values of all of them, or was it just that one?
It's just that one.
Yeah,
Just
just
A
that
and
one.
B?
I think so. I completed the whole thing just because it's so easy on Excel. But
Alright.
I think we only needed A and B.
Okay.
Okay, so 13, the quantity is equal to the sum of the numbers in the squared deviations column. What quantity is equal to the sum of the numbers in the squared deviations column? Well, let me go back to my spreadsheet and I'll just sum those up. But it's, well, actually, never mind. What would that be? Would that be the standard deviation?
I think is it not the variance because it's how much the whole thing varies. It's not just the standard deviation.
Oh, probably.
I'm not positive, but that's kind of what I was thinking because the standard deviation wouldn't be the deviation squared. It would just be the standard deviation.
Right. So would that be like taking our largest number and subtracting our smallest number? Is that
Yeah,
the
I think so.
variance?
Yeah.
I think so.
Okay, let me try that real fast. So when I add them all up, when I add up the squared deviations,
Yeah.
I get 1.5341. So I'm trying to find where that would fit. I mean, it's definitely not the mean. I think you're right. I think it's either the variance or none of these.
Yeah. What's the point of even getting the squared deviations again? Like when
I
you
don't
square
know.
them?
I don't know for sure either.
Here, let me look up what the variance is real quick. Yeah, it's variance.
It's variance.
Yeah, it says in probability theory and statistics, variance is the expectation of squared deviation of a random variable from its mean, and it informally measures how far a set of random numbers are spread out from their mean.
Okay. Awesome. Yeah, I think that's the best answer then. So 14 wants the standard deviation. And so you guys can double check my answer, but I got 0.715.
You just put that in your Excel,
Yeah.
0.715.
Yep.
Fifteen is false, isn't it? Standard deviation can never be negative.
Yeah, it's false.
I just believed you on 14. I was done 14.
I figured. What about you, Daniel? Have you double checked that, or are you fine with
I'm fine with your answer. You
0.71?
got Excel right there, so.
Yeah. Okay. 16 is the extradural. And you can
What does
see
that
it,
even mean?
it has
Because
the
the lowest
small,
standard deviation.
Yep, exactly. And then the next one is 8. 17 is 8.
Okay.
Then what percentage of the data lies between 4 and 8 hours? That's 50%, right?
I'm not sure. What does the data underneath that box thing represent? So you have these other, like the two extreme ends, aren't those like the outliers, and then like basically the average of everything else falls between the two ends of the boxes, the box?
Yeah, so the mean is at 6.
So, yeah.
But I can't remember if the box represents 50% of the whole thing or more than that. I'm pretty sure it's 50% though. I'll look it up real fast.
Oh, it's the third and first quartile. So yeah, 25 to 75%. So yeah, I think that
Yeah,
that
so
would be 50%.
50%. Yeah, I'm pretty sure.
Okay.
Sweet.
So 0.50.
I think you actually just put 50.
Yeah.
Oh. Oh yeah. Okay. Cool.
Okay, well, I hope you guys know how to do this next section.
Let's see. I'll go ahead and read it. An observation from a normally distributed population is considered unusual if it is more than 2 standard deviations away from the mean. There are several contaminants that can harm a city's water supply. Nitrate concentrations above 10 ppm parts per million are considered a health risk for infants less than 6 months of age. The city of Rexburg reports that the nitrate concentration in the city's drinking water supply is between 1.59 and 2.52 ppm, and values outside of this range are unusual. We will assume this is a sample, that's a population sample minus 2 deviation or standard deviations equals 1.59 ppm. Okay, so we got that thing down there, equation. It is reasonable to assume that the measured nitrate concentration is normally distributed. Okay, so if it's normally distributed, then the samples are going to be normally distributed. So, so we have the okay. So the concentration of the water supply is between, estimate the mean of the measured nitrate concentration of Rexburg's drinking water. Okay.
Yeah, I'm having a hard time wrapping my head around this one.
Okay. Is it unusual if it's more than 2 standard deviations away from the mean? Okay. There are several contaminants that can harm. Blah, blah, blah. Okay.
Is like the first part irrelevant, like the nitrate concentrates above 10 are considered a health risk for, I feel like, isn't that part irrelevant to what we're doing?
I don't see how it ties in.
Yeah, me either.
So I just want to forget about that because it's just like more information that's confusing me.
Yeah.
Oh,
So estimate the mean of the measured nitrate concentration. We only have 2 measures, so do we just average those 2?
The 1.59 and 2.52.
Yeah.
Yeah, I can't. That seems like it would be too easy.
yeah,
I
it
agree.
seems too easy. I mean, I don't see how else to do it though.
Man, okay. I wonder if there's like, let's see, what lesson would cover this? Maybe we're supposed to use that equation to find like the mean, or so we do like the value of uh, x hat, so like the population mean. So we have two samples, so maybe we need to do that like standard deviation sigma over, no, what is that? Okay, let me look it up. Yeah, like sigma over the sample size. Okay, I'm not even sure.
Yeah,
So they gave us, okay, so they say, so it's u minus, so we don't know what I think there's a formula to find, so they're asking for the mean of the measure, so that's not the same thing. Yeah, I don't know. I think maybe we should just go ahead and just average the two samples.
yeah. How about you try that real fast? And I might be able to confirm it because I actually know the answer to number 21 because it was a multiple choice one that I got.
It's a good guess.
Okay, I got 2.055.
Okay, so yeah, 21. I got that one right, and it was the 1.823 and 2.288, and when I average those, I get the same answer. So I think we're probably right.
It just seems so easy.
Yeah.
Ridiculous.
The 2.055.
0.05.
Yeah,
I
sorry,
mean,
yeah, 2.055. Yep.
but it might be 0.56, right? Because it's 0.0555.
Is it?
Oh, they say round your answer to 3 decimal places.
Yeah.
Okay. All right, cool. And then the standard deviation.
Oh boy.
Okay, I got 0.658.
So did you just plug that into Excel?
Yeah.
I want to do that real quick.
I got a calculator up right here. What do you do to find the standard deviation?
I don't know the process with the calculator. I
Yeah.
am handicapped by
Okay, that's
Excel
cool.
functions. Okay, I think this next one we're gonna have to use the applet. If someone wants to get that up.
I have it up.
Awesome. I'll go ahead and read it. The admissions committees for most Masters of Business Administration programs require the Graduate Management Admission Test, the GMAT, as part of the application for new students. It has been shown that the scores on the GMAT are normally distributed with a mean of 542.3 and a standard deviation of 120.54. The minimum GMAT score required for admission to MACC program in the School of Accountancy at BYU is 500, but it is rare for students with scores less than 600 to be admitted. What is the probability that a randomly selected student will score above a 542.3 on the GMAT?
So they got I think so. Did we take the 542.3 minus no. That's the actual, that's the population mean, right? So we're gonna do like the sample mean minus population mean over
So we
sample square.
we need to find the z-score, right?
Yeah. And then so to calculate the z-score, we used that one formula we used like last week, which was, let's see, where is it? Yeah, I think it's like the sample mean minus the population mean over sigma divided by samples squared for like the standard deviation.
Yeah, I mean, is there the chance that, because in the introductory paragraph, it says that the mean is 542.3, and it's asking what's the probability that a randomly selected student will score above 542.3. So is there the chance that it'd just be 50%?
Sorry, guys.
Right, because that's the mean.
Yeah.
Oof.
Sorry, guys, to go back, but I didn't get the actual decimal for 20.
So 0.658.
And then 21 was the fourth one.
Yep.
Okay, sorry about that.
No, you're
That's cool.
no worries.
It's good to ask though, you know, rather than taking a hit to your grade.
Yeah.
That's interesting. Maybe the 50% thing. I don't know. I think we could go ahead and like solve the formula for it, and then we could see just to make sure.
Okay, right.
So let's see. The sample in this case is, says x minus x hat over standard deviation. Did they even give us a sample deviation? Because all I can see is this 542.3 thing. That's like the only like relevant data.
Well, they do give us a
The
standard deviation.
120.54.
Yeah.
Right. Okay.
That gives you like an incredibly low z-score, though.
Yeah, so it can't just be that divided by, it can't just be the mean divided by the standard deviation.
It doesn't give us the size, does it?
No.
So, you know, maybe it is 50% because we don't have enough data to actually do the formula.
That makes sense to me.
Okay. They don't tell us how many decimal points, or I guess we could put in 50? No.
0.5.
0.50 or 0.5. Does it say like how many decimal points to put unless told otherwise around the top? I'm gonna check real quick.
It says 3.
Okay, so unless otherwise specified, just use 3.
So it'd still just be 0.5 because 0 doesn't matter.
Yeah. Okay, for the next one, let's see.
Okay, they scored below 600 on the GMAT. Oh boy. Man.
Isn't this one just 600 minus 542.3 divided by 120.54? And that gives us our z-score, and then we'll shade everything to the right.
Yeah, I think you're right. So I
Yeah.
actually did that on Excel already, and the z-score that I got was 0.478679. I put it into the applet, and you say to shade everything to the right of that?
Yeah, because it's everything above, right?
Right. So I got for the area as 0.316. But you guys can double check that if you want.
Yeah, I'm gonna double check it real quick.
.316.
Yeah.
That's what I got.
Awesome.
Alright, yeah, let's go ahead and move on.
0.316.
Oh, that was below. That 23 was below. So
Oh, okay.
the answer for 24 is 0.316.
Okay, 0.316, and then the other one would be 0.684.
Yep.
Okay, find the GMAT score that corresponds to the 10th percentile.
Sorry guys, what was the answer on that last one?
For 24?
424?
No, for question 24 or 23?
23.
0.684.
Oh, so did you do above and below?
Yeah, so 23
Okay.
is 0.684, and then 24 is 0.316.
Cool, thanks.
On this next one, I think that, so now that we have the z-score, we put the z-score in and we just solve the formula for the variable for x, and then we put it back in.
Oh, okay. Yeah,
You know
that
what I
makes
mean?
sense. Yeah.
So what was the z-score again?
The z-score for
0.479.
yeah, it was 0.479, but that was with the value of 600.
Um,
I think that we should stick to that.
First quartile. Yeah, we really. I wish I knew how to do this. I was more confident knowing how to do this because the next few questions are all
Based on
finding
these?
what the value is for a certain percentile.
Okay. Let's see, I think the last lesson talks about that.
Because what you were saying, Jake, I think that makes sense, but I just, with the value, with our z-score being dependent upon a value of 600, I don't know if we carry that over or not.
Yeah.
Dang it. I'm looking around. I don't see where they talk about which lesson has the finding like a certain percentile.
Oh, do you know what I think the z-score is negative 1.28 because I put in point 0.1, which would represent the 10th percentile on the normal probability applet, and it puts the z-score at negative 1.28. And so then I think that we plug in negative 1.28 and just solve for x.
So you did negative 0.1.
I just did 0.1 on the area, which gives us the bottom 10th percentile. And it gives us a new z-score of negative 1.28.
So that would be true then, no matter what sample size or whatever we're looking at.
Yeah.
You just well, let's see. Well, we're still looking at the GMAT score. So if we're looking for the GMAT score, then I think it depends on using some of the data that we use to solve like the earlier questions.
Huh. I think you might be onto something, Jake. I think that could probably work, just doing it backwards.
That's what I was like watching some of the tutorial videos this morning to try to like learn a little bit more, and that's what he did. So like if you get the z-score negative 1.28 and you times it by 120.54, which is the standard deviation, then you get negative 154.291, and all you do, just a sec. Then what you do is you subtract, you add 542.3.
So you basically what you decided to do is you put in, well, it already actually had it when I brought it up. So negative, you put the z-score as 0.1.
I
So you put the
put
z-score as 0.1.
no, the z-score point is negative 1.28
Oh,
because you put in 0.1 into the area because you're trying to find the 10th percentile.
uh-huh.
And so you put in 0.1 into the area and it gives you the z-score. And
Is
the z-score is
1.645.
negative 1.28.
Okay. I didn't get that. I got something else.
Did you put 0.1 into the area?
Yeah. I got negative 1.645.
Really? Huh.
Hmm.
If I put into 0.1 into the normal probability applet, I get negative 1.28. What do you get, Brady?
I what do I get on the applet?
Yeah.
Yeah, what do you get for z-score?
So right now, so it keeps kind of changing between zero point 0.1 and 0.0999, but my z-score is negative 0.282.
Wait, your z-score is negative 282?
Or sorry, 1.282.
Okay, yeah, that's what I got.
Yeah.
Negative 1.28.
Yep. Right.
Yeah. And so then
Okay.
I'm doing it right here on my calculator, and I got an answer of 388.
That seems to make sense. I mean, given that the mean is 542.
I think that, honestly, I think that's how we do it. I'm not positive. If we get it wrong, I don't know, but I'm pretty sure that's how we do it. I can't
Okay.
find it. And I think we did the exact same for 26, except for we just put zero point 0.9 into the area.
Right.
And then the
Yeah.
exact same for 27, we just put 0.25 into the area, and
Yeah.
so on.
I.
I mean, that's what we
I.
do for all of these.
Right. I'm fine.
Hmm.
Trying that out. So yeah, it's
That's weird.
if we put zero point 0.9 in the area,
It's the same.
it's the same z-score.
Yeah. And so then all you do is the z-score is positive though.
Yeah.
So
Oh man.
I got 696.8. So this is around to the whole number, right?
696.8. So 697.
Yep. That's what I got.
Okay. Yeah, I'm
Hmm.
fine with that. And then for this next one, so it would just be 0.25, right?
Yeah.
All right. I keep getting a different z-score. So to start out with, I'm like on a different page than you guys are.
What z-score are you getting?
So when I put in 0.1 on the area for the probability applet, I keep getting 1.645.
Do you have just the bottom? Do you have just the left part shaded?
No, I have left and right.
That's why.
It doesn't make a difference though when I unshade it.
It probably changed your area.
Well, it did change the area once I unshaded the.
Yeah.
Okay.
So like right now, did you put the same answer for 25 and 26 that we did?
Oh, hey, I just solved it. Okay, so it's 1.282, right?
Yeah. So,
Yes. So, okay.
so like on this one we're on 27.
Uh-huh.
Just shade the left side and put 0.25 in the area, and it'll give you a z-score of negative 0.67.
Gotcha. Okay, and so once you get okay, now that I figure it out, so I was just shading both sides. I need to shade
Yeah.
one side. So now that I got that done, um, what did you do after you enter in like the certain like percentile for the area?
You multiply it um, by the standard deviation because you're just solving the equation.
Uh-huh.
And so to get the standard deviation off of the right side of the equation, you just multiply it onto the left. Um, and then you just add the mean, which is 150 or 542.3 or whatever. Do you know what I mean?
Yeah.
You just solve the
Yeah.
equation at that point because you have the z-score, you have the population mean, and you have the standard deviation. So you're just trying to find x. So you just solve the equation at that point.
Okay. Okay. So then yeah, you multiply the z-score by the standard deviation and then add the population mean.
Yeah, exactly.
Okay. Cool. Well, thanks. All right, I'll catch up. Let's do this on Excel. It'll go a lot faster.
Okay, so I've been working from the bottom up, and so I think I've got 31 and 30 done. Have you been able to figure out the 25th percentile, Jake?
No, sorry, I was trying
No, he
to.
was helping me figure it out.
Yeah. Oh, yeah, that's right.
I got what is this? What number? 27. I got 461.
Okay. That seems
Daniel,
to make sense.
were you doing 27 also?
No, not yet. I just
Oh,
finished 25.
okay. Did you get 697?
Yep.
Okay. And 388 for 25?
Me for 26.
For 25, I got 388, and then for 26, I got 697.
Oh, I was doing them backwards. Okay. Okay.
So on Brady, you said that you did 30.
Yeah, 30 and 31 and 29, but I am a little unsure on 29.
Okay. Just like let me do 28.
Okay.
Okay, so on 28, I got 623, or actually 624.
624 for 28.
Yeah.
Awesome.
Yeah. Same here.
Awesome.
Okay.
Sweet. So 29, consider the simple random sampling of n equals 15 students taking the GMAT. What is the mean of the distribution of sample mean scores for all such samples? I forget, for these, do we just take the same mean that we were already given? Or is it different?
It's the same mean, like for the population mean.
Yeah.
Yeah, I think we use the same one.
So just 542.3.
Yes.
Okay. Now the next ones I am pretty confident on, but probably be good if you guys could double check. So for 30, what's the standard deviation of the distribution of sample mean scores for all such samples? So I have 31.123.
Wait,
Okay.
sorry, just one sec. On 29, you guys are just putting 542.3 or whatever.
Yeah, doing that divided by was it the square root of
15.
15?
That's all you have to do.
Wait, so that's what you're doing for 29?
That's what I'm doing.
Um,
I think that's what.
What did you get, Daniel?
I got 140.021, or in this case, one decimal place, so 140.0. Consider a random sample of. Okay, so let
Because
me just go back real quick to the last lesson and just read about the mean of the distribution of sample means, just to
okay,
make sure.
that'd be great. Okay, so Jake, for 30, if you want to kind of double check what I've got. So
okay.
what's the standard deviation of the distribution of sample mean scores for all such samples? So what I did was I took the square root of 15, which
Uh-huh.
is 3.87,
Uh-huh.
and then I um, took the standard deviation of 120.54 and divided it by 3.87. And that gives us 31.123.
So you just took the standard deviation and divided it by the square root of 15.
Yep.
Yeah, I'm really not that sure. 31.123.
Yeah.
Yeah, I'm not really sure how to run that problem. If that's the way we run it, then that's definitely the answer.
Yeah. I think that is. I'm going to double check with the last lesson. Any
I
luck,
think
Daniel?
Yeah, so yeah, we were correct when we used the 542.3.
So is that the answer, or are we dividing that by something?
Um, so we, hmm. Okay, I actually haven't seen that. So I haven't seen it cover. All I did was look up the definition of the mean and the sample means, um, to make sure we got that part right. I haven't seen though like any formula where you divide it by. I mean, there's the regular finding the z-score formula where you take it. Basically, you take the sample mean minus the mean of the distribution of means over standard deviation to find the z-score. But we're
Uh-huh.
not really looking for the z-score right now. We're just looking. It says like consider a random sample of 15 students taking the GMAT. So what is the mean of the distribution of sample means for all such samples? Um, so I'm inclined to just go with 542.3 as the actual answer. In this case, the sample size is irrelevant, but I'm not 100% on that, so I'm still looking.
Okay. Yeah, I'm fine with that too. Um, and Jake, I'm going through, and it looks like to find the standard deviation, we were doing it the right way with 120 divided by the square root of 15. Does that
okay.
sound good to you, Daniel?
Yep.
Okay. Awesome. And then for the last one, what's the probability that the sample mean GMAT score for an SRS of n equals 15 students will be greater than 600? And so I put in 600 as the value, subtracted by 542.3, and then divided by our new standard deviation, which gives us a z-score of 1.853917. And then I plugged that into the applet, and I got 0.032. Because it's going to be a really low probability because we're shifting, it's the probability of the entire mean shifting above 600, right?
Yeah.
You got a z-score of 1.853?
Yeah.
Okay.
And then I just plugged that into the applet, and I got 0.032.
Okay, you know what? I'm actually think for question, and I think you're right on that last one. That makes sense.
Uh-huh.
I think we should fit 140 though as the answer for 29 after all. So what I just did then is I just took the 542.3 and divided it by 15 squared, or the square root
Uh-huh.
15, and so I got 140.0.
Would it not be 542.3 divided by 120.3 divided by the square root of 15?
Yeah, Jake, you're right. Okay. Nice catch. Yeah, totally. That's the way to do it.
And
So-
what was that again, Jake?
Oh, 542.3 divided by 120.54 divided by the square root of 15.
That's right. Exactly.
So what'd you guys end up getting?
I got 17.4.
Just a sec. This calculator's kind of hard to write on. $17.424.
Yeah.
That's what I got too.
And you got that by dividing the mean by the new standard deviation?
Yes.
Yeah, so we did the mean over the standard deviation divided by, so it was the mean divided by the standard deviation divided by the
The square root of 15.
15, yeah.
Okay.
And just
Cool.
go to one decimal place, is that what they said? Yeah. So
Yeah.
0.4.
Oh,
And so that was what again? 17.4.
4.
All right.
The moment of truth.
Yeah.
Oh boy.
Daniel, do you want to submit it or do you want me to?
I got it.
Okay.
Crap. So I got 0.33 on question 2 because I checked all the boxes. Oh, the number of animals in the local zoo, that's totally not categorical. Huh. I don't know. Maybe let's just move it to.
I
So-
think the age in years wouldn't be categorical also because Brady, didn't you get that one wrong?
So I had the first two selected, and I got 0.6 out of 1.
So I wonder if it would just be a randomly selected random toothpaste.
Yeah, probably. Okay. Then. Doing good, doing good. Oh. Okay. Wow. So 13 wasn't correct. It's not the variance. So I guess it's probably none of these is correct.
Yeah.
My bad.
It's all
I
good.
also got 11
Yes.
wrong.
We got 11
11?
wrong.
Yeah, so it's not 0.165.
Did we get 12 right, though?
Yes.
What? That's weird.
Yeah.
How does that work?
I mean, are we supposed to put a negative in?
I think so. Yeah, you can. I mean, so
Yeah, I assuming it would just be negative 0.165.
uh-huh.
Okay.
That's weird. Okay. So going on. Oh crap. So 16 was wrong.
Wait, what'd you put for 16?
Arterial.
Oh, that's extradural.
Yeah, extradural.
Sorry, I'm
So,
not sure how I didn't tell you that. Yeah, we knew that one was extradural.
oh, okay. Yeah. Well, hey, that's my bad. Alrighty. Um, cool. So this one's right. We got these ones. Okay. 20. We got wrong. So I put in 0.658.
Yeah,
Okay.
that's what I got.
Yeah, me too.
And then
But we got 19 correct.
let me check. Yeah. So 2.055.
Wow.
Yeah. And then we got 20 wrong.
Yeah. Yeah.
That's weird because I have that
That
right in front
works.
of me. I just plugged in the two. I mean, unless we were supposed to use another uh, number, I just put in 1.59 and then 2.52 and did the
Found the standard
stdev function.
deviation.
Yeah.
Yeah. Yeah, I would have done the same thing. So I don't know why that didn't work.
What's the standard deviation of 2.055?
Um, well, you need at least two numbers in
You
order
need
to find a
two.
standard deviation, right?
So what if we put all three of those?
Oh,
Oh. Hmm. Interesting.
so if you go to question 21, so we know that 68% of the data lies within one standard deviation of the mean, and we know that the answer is 0.823 and 2.288. And so if you take 2.288 and then minus the mean, won't that give us the standard deviation?
I guess, yeah, it should.
So I got 2.232.
Yeah, that's what I got too. That makes more sense.
Yeah. Weird that the
So you're
answer
looking
from
at
Excel was so off.
for question 20 when you take like what you said when you put in like the you add the 2.055. Um, so I got the standard deviation was 0.465. So when I
You
did
just,
that, so I took the two other values that you took, Brady, and then I
Uh-huh.
also added the 2.055, the mean of those two values, and the standard deviation is totally different than the one we put in. So maybe that's the right one. It's 0.465.
Point.
all we did for
Just to find the standard deviation.
all we did was take 2.288 minus 2.055
Oh, so you just minus. Oh, okay.
because like on 21 it's saying it's one standard deviation or whatever
Mm-hmm.
away from the mean. And so if it's one
Yeah.
standard deviation away from the mean,
Oh, yeah, yeah, yeah. Okay. Sorry, I
Yeah.
wasn't even listening. Okay, yeah, that makes total sense though.
Yeah. So 2.055 for 19 and then
Mhm.
0.232 for 20, right?
232.
Yeah.
Okay, I got 233.
Oh, 233. Um,
Let me check. Yeah, I got 0.233.
233. Okay.
Because yeah.
Sounds good.
All right.
What other ones did we miss?
We're good until crap. Okay, so for question 29, that was 17.4 was wrong.
Do you want to try
I don't know
the
how the crap that happened.
2.3?
Try what, Jake?
Did you want to just try the 542.3?
I'm fine doing that.
Okay.
And then what about 30 and 31?
542.3. Huh. And okay, so and then I didn't actually even submit an answer for 30, so I don't even know what that is. So I got false. Sorry about that. Wrong guy to submit. And then we got 31 right.
Nice.
Okay, I'll submit mine now.
Alrighty.
Yeah, we got them all right.
Boom.
Heck yeah.
Nice.
Nice work, team.
And so for 2, we only selected the middle one, right?
Yep.
Okay.
Perfect. I actually got one wrong since I put false on the first one. But
So what was the answer for 30 then?
30 was 31.123.
Okay. Cool.
Cool.
Sweet.
Hey, thanks guys. Sorry,
Yep.
I was really out of it today. I'll be a lot more prepared next time.
No worries.
No worries, man.
Good team effort. That took way longer than our other ones, though, with
Yeah,
there
dude.
being so many more questions.
Yeah, I did.
Exactly.
Okay, well, good luck on the exam. I mean, I don't know if we're going to meet together before we all take the exam.
All right.
Yeah, good luck, you guys. Daniel, what were you saying about the tutoring? How do you do that online?
I think so. You just go to like tutoring on. So you just go to like BYUI tutoring.
Okay.
You, like type that into your search engine. And then like they should have like the tutoring center. So like you just go to like online tutoring options.
Uh-huh. Okay. Sweet, man. Thanks
Yeah,
a
and
lot.
then they got like tutor request up there, and yeah. So you just talk to somebody live, and they'll go over the questions
Sweet.
with you.
So,
Sweet,
Jake,
man.
where are you?
I'm in Texas.
Oh, okay. Just
I'm
living
doing
in a hotel room?
Yeah, we're actually moving into our house today. So, I'm doing summer sales, and
Nice.
they bought us a house, but they hadn't closed on it, and so they just barely did, and we're moving in today.
Okay, sweet.
Cool.
So, yeah, yeah, I'm excited to get out of this stupid hotel room. So,
Yeah. Yeah, this whole time I've tried to figure out like what apartment that was. I'm like, is that like the R-Pad or something? Some old motel they turned into an apartment, but that makes sense.
Yeah, sweet.
Cool.
Well, good luck,
Cool.
guys.
Yep, you too.
Okay,
All
have
Good
a
work,
right.
good
team.
Take
day.
care.
We'll see ya.
Bye.